Hello and welcome. In this video series, I am going to talk about exceptions. We are going to start with an introduction, then discuss the difference between checked and unchecked exceptions. Next, I will demo 4 common Selenium exceptions, then show you how to handle exceptions. Let's begin with a diagram of the exception hierarchy. We see throwable at the top. All exceptions are derived from the throwable class. Error and exception are 2 subclasses of throwable. Error is related to a problem in the JVM, Java Virtual Machine, while exception is related to a problem in our program. The focus will be on exception because an error is beyond our control since it involves the JVM. What is an exception? An exception is an indication that something is wrong with our program. We can explicitly throw an exception when a condition is met, or the exception will happen automatically because something did not complete. Checked and unchecked are the 2 types of exceptions. Checked exceptions are exceptions checked at compile time. This means the compiler will check to make sure our syntax is correct before running our program. Unchecked exceptions are not checked at compile time, but they are checked at runtime. A better name for an unchecked exception is a runtime exception. A runtime exception is when the syntax is correct, but the logic may not be correct. As a result, we run our program, then receive an exception at the time of execution. There are so many exceptions, but here's a list of 3 checked exceptions and 3 unchecked exceptions. We also have a list of more checked exceptions and unchecked exceptions. I included a link to the Java docs if you want to take a look at all of the exceptions. Click Runtime Exception and you will see more runtime exceptions. Next, we are going to look at 4 common Selenium exceptions. Hello and welcome. My name is Rex Jones II. Feel free to connect with me on LinkedIn and subscribe to my YouTube channel. When you subscribe, click the bell icon to get notification of each video. In this video, we are going to discuss and demo 4 common Selenium exceptions. The 4 exceptions are no such element exception, no such frame exception, no such window exception, and element not visible exception. There are more exceptions in Selenium, such as no alert present exception, no such session exception, stale element reference exception, timeout exception, and many more. However, we will demo these 4 common exceptions. What is an exception? An exception is an event that happens at runtime. It stops our program from running and does not provide our expected result. The first exception is no such element exception. This means the element we are trying to locate does not exist. There are 3 reasons for a no such element exception. First, the element may not have been rendered on the application. This could be a problem with the application, or the previous test step failed in our test script. Second, we could be searching for an element before it is rendered on the application. Selenium is very fast and it's trying to interact with an element before the element shows up. If that's the case, we can add a wait statement before searching for the element. Third, we are using an incorrect locator or locator value to find the element. The demo illustrates number 3. This test script has a name locator and Q1 as the value. Q1 is not correct. The correct value is Q, but I added 1. If I execute, then the program will not send a test into the search box. Failed. No such element exception. Unable to locate element. Method name selector Q1. Next is the no such frame exception. We come across this exception with frames and iframes. There are also 3 possible reasons for no such frame exception. Number 1, we switch to a frame that does not exist. This scenario happens when we enter an incorrect index, web element, name, or ID for a frame. Number 2, switching to a frame that's inside of another frame. And number 3, not going back to the parent frame before switching to a different frame. Numbers 2 and 3 can happen if we have more than one frame. Imagine we switch from frame 1 to frame 2, but want to go back to frame 1. The exception is thrown if we don't go back to the parent frame using the switch to default content method. Our demo shows driver switch to frame 34. The correct value should be 2 and not 34. Therefore, this frame does not exist. Let's run. Failed. No such frame exception. The no such window exception is next. There are 2 possible reasons for this exception. First, switching to a window that no longer exists. This can happen if our automation code does not close a particular window without reloading the list of windows using the get window handles method. Second, switching to a window before invoking get window handles method. Let's look at number 2. Do you see line 66? Driver.getWindowHandles method. This method gets all of the window IDs. The code is not correct because the previous line 65 tries to switch to a different window before calling the driver.getWindowHandles method. We already have the main window ID at line 58. So this code will run without an exception if we remove line 65. Nevertheless, let's run. The main window ID is good, but our test script failed with no such window exception. The last exception is element not visible exception. This exception happens if we try to interact with an element that's not visible and our automation code missing a dynamic wait statement. Number 2 goes back to Selenium, which runs the test script at a fast rate. Let's demo number 1 on Amazon's site. Do you see how there's a drop-down list for account and list? More options show up after hovering the list. All of these options are elements not visible to Selenium unless we use Selenium's actions class. In Eclipse, I commented out lines 94 through 98 to hover the drop-down list. Therefore, when I run, we should see an element not visible exception. Our test script failed. Element not visible exception. These 4 exceptions, no such element exception, no such frame exception, no such window exception, element not visible exception, are examples of what could happen when writing our test scripts for Selenium. Thank you for watching 4 common Selenium exceptions. Next is how to handle exceptions. Before talking about how to handle exceptions, let's talk about why we should handle exceptions. Recall from the introduction, an exception is an indication that something is wrong with our program. Perhaps the logic is wrong and we need to correct it or throw an exception, catch an exception. Let's go to Eclipse. Start with the main method and the value. Int value equals 34 divided by 0. Print the value. Concatenate the value. We are unable to divide any number by 0. So 34 divided by 0 is not a valid operation. The syntax is correct, so there is no problem when running our program. Notice the program terminated without printing a value. However, we see an exception. Read the exception from bottom up. The package is com.selenium for beginners.java.exception handle. The class is no exception handling. Main is the method. No exception handling.java.7 shows the class name and line number with a problem. The previous line is the exception, showing exception in thread main. Java lang.arithmetic exception divided by 0. This means there is a problem with our logic. Click the line number and we are directed to the root of our problem. How to handle an exception? We handle exceptions using 4 keywords and a test framework. Try, catch, test ng is the test framework. Throw, throws, and finally. Try and catch are the core of handling exceptions. Try is used to monitor code that may cause an exception. Catch is used to handle an exception if an exception is thrown. We can choose to add more than one catch statement to handle an exception. What's the purpose of handling an exception? The purpose is to give power to our code. With that power, our code can respond to any problem, then continue running our program. Let's take a look. Copy the previous code. Write try, control space, copy the code, and place it within the brackets for try. Exception is the type of exception, and E is the object that stores a value after catching an exception. However, I'm going to change exception to arithmetic exception and E to EXC. I changed exception to arithmetic exception because arithmetic exception is the type of exception that happens after dividing by 0. Add a print statement, sysout can't divide by 0. We can also call some methods by writing EXC, the object, and the dot operator. And some methods are get localized message, get message. We also see get stack trace. But I'm going to leave off calling an exception. Let's run. Can't divide by 0. This is how we handle exceptions. In this example, we know the exception is arithmetic exception. Copy this code and paste the code. So we know the exception is arithmetic exception. If we are not sure of the exception, then it is common to add multiple catch statements. Each catch statement must be different. Let me show you the superclass, which is exception, since it deals with all program-related exceptions. Write catch exception E, and write a print statement. There is a problem, and run. We see the same print statement, can't divide by 0. If we use exception, then it must be placed in the last catch statement. Look what happens when we add exception before arithmetic exception. Unreachable catch block for arithmetic exception. It is already handled by the catch block for exception. Everything after the superclass exception cannot be reached. Change it back. We can also handle exceptions using the test framework, testng. There is an attribute called expected exceptions for the test annotation. All we need to do is pass in one or more classes. The purpose is to list exceptions that a test method is expected to throw. So far, up to this point, we have caught exceptions created automatically by the JVM. The throw statement makes it possible to manually throw our own exception. We write keyword throw, new, followed by the name of the exception class. A method must declare an exception in the throws clause if the method generates an exception that it does not handle. However, the throwable subclasses error and runtime exception are not required in the throws list. All other exceptions will show a compilation error. If there is an exception or not an exception, the finally block of code will always execute regardless of the condition. Let's go back to Eclipse. Copy, paste. Say, for example, we have a database connection, network connection, or maybe a file that's open. At the end of the try catch block, we can add a finally block and a print statement. Sys out, close the open file, and this block of code will always execute. Let's run. And we see can't divide by 0. Close the open file. Remove the exception by changing 0 to 2. Let's run again. There is no exception. Value equals 17. Close the open file. The print statement for finally also showed up. That's it for how we handle exceptions.
Online courses coming soon. Books available in paperback, ebook, and PDF. All Part 1 ebooks and PDF documents are free. Programming books for UFT. Programming books for Java. Here's the Selenium automation book. And TestNG. Subscribe to get notification of future videos. Don't forget to like, comment, and share.